Welcome to the next session in the Application Evolution series. This session is going to explore evolving your applications for availability and security. So why do we want to evolve our applications for availability and security? Well, from an availability point of view, the world has evolved. There was a time when businesses were open for set hours, your applications were online for set hours, you were able to do batch processing off hours, and you could take a system offline on weekends in order to apply maintenance and upgrades. But now we live in a 24/7 world where users want to access the application at any time of the day, any day of the week. And so you will want to evolve your applications to meet those expectations. The OpenEdge platform to meet the industry standard of 5 nines. We will do that by making the platform available to that standard. Individual products may not achieve the standard, and there may be redundancy built in, such as clustering and failover, in order to achieve the objective. In fact, the new standard in the industry is called 5 nines, which means 99.999% availability. This translates to 6 minutes of downtime for your application in a year. Progress has an initiative in place which we call our 5 nines initiative, which is we have been talking to customers for several months now about what is coming out in OpenEdge 12. And here is feedback from one of our customers who said continuous availability is critical, that any downtime, even planned downtime, is still downtime to the client. And I can second that. I bank on weekends and evenings, and if I find my banking application is offline, I'm disappointed in the service I'm getting from the bank. So availability expectations have changed, but so too has been the way transactions happen. If you go back 30 years, most transactions were done by going to a brick and mortar store, securing the product, paying for it in cash, and that was the end of the transaction. But now transactions are different. Many are done online. They often involve a credit card. You may apply for a bank loan online, and in doing so provide financial information and a social security number. And the expectation when we do transaction online is that the application provider is securing our data in the process. So users expect a secure environment, and the challenge we have is to maximize availability and provide transaction security at the same time. In this presentation, we will cover 3 topics. The first is going to be what we've done to improve availability of the OpenEdge platform. Second, when bad things happen and an application does go down, what have we done to improve the recovery time of that application? And then I will cover security enhancements that have been added to OpenEdge over the last several versions of the product. Let's start with the improvements we've done in application uptime. When we think about improving application availability, we need to look at what limits availability. And there are really 2 enemies of uptime. The first are unexpected system outages, a hardware failure, or a flood, or a fire, or a power failure caused a system to go offline. And the other is that we need to apply maintenance to the product, and we also want to add additional capabilities to the product. In version 12.0, we've added a couple utilities to help you monitor the health of your system and give you the ability to take actions before a customer experiences a service disruption. The first utility we added is a health scanner. The health scanner works with the Progress application server for OpenEdge, and it works much like the check engine light in your car, with a couple of key differences. The check engine light in your car is either on or off. If it's off, everything is working well. If it's on, there is a problem, but you really don't know what the problem is. With our health scanner, you can define the components of the system that are important to your application, such as the health of the operating system, the disk space availability, how memory is being used, is the network healthy, and so on. Once you define the different components that are important, you can assign a weight to each individual component to indicate that one resource is more critical than another. You can observe in the screenshot that a component with a higher weight is displayed using a larger rectangle. You can also set how often you want to poll the information, anywhere from 1 minute to beyond 1 minute. The scanner can display 3 user-defined health levels for each component. A green state that indicates a component is healthy, a yellow state that says I'm in a marginal condition, and then eventually a red state that says I'm failing. The purpose of this utility is that you can monitor your system while it's running and take action to resolve any disruption before it impacts the user. Another change we've made to the Progress application server for OpenEdge is enhancement to the online production profiling tool. The new profiling tool helps you identify memory leaks, identify inconsistent and long execution times, and analyze code faults. Customers that have migrated to the Progress application server often find memory leaks that went unnoticed with the classic app server. This tool becomes invaluable in problem determination and resolution. The tool works by extracting information and sending it to a diagnostic store on a second server while your application is running. Now, many operations people and developers are reluctant to do profiling or monitoring of a production application because it takes resources away from the user application. In this case, we're dumping it off to a diagnostic store so that we minimize the impact on your production environment. The way you access the information in the diagnostic store is to run some supplied code, which does some compilations and displays the information into the Progress Developer Studio. This provides you a view as to how your operations and productions are performing. The 2 tools I've talked about so far are both tools for the Progress application server for OpenEdge. In version 12, the Progress application server for OpenEdge is the only application server being carried forward. The classic app server continues in version 11 of our products, but will not move forward into version 12. Now, beyond adding some monitoring tools, we also have done some things to improve application delivery as we begin our journey towards the 5 nines. The changes to achieve 5 nines availability will happen over several iterations of the OpenEdge product. Version 12.0 is our first step in that direction. In version 12.0, we have made web application deployment easier. Typically, when you launch a new application, you're required to restart the server. In version 12, you can launch a new application without server restart. We believe that this is best used when launching a development environment, a QA environment, or a test environment. When truly launching a new application, we would still recommend that you restart the server so the new application becomes active in a pristine and known environment. A second improvement that we've done in application availability is the ability to do online ProPath updates. The online ProPath updates allow you to change the ProPath without shutting down the system. Existing requests will finish under the original ProPath, and any new requests will execute under the ProPath change. This allows you to update a server to a new level or roll back an application to a previous version without disrupting your users. This is a powerful tool, and with that power comes responsibility. You will want to secure who has the ability to make ProPath changes, as well as retain an audit log of changes to prevent a rogue actor from inserting unintended processes into your application. In version 12.0, we've also made changes to online operations for various SQL tasks, such as dropping an index, renaming an index or column, and also doing some configuration. These changes create the foundation for future enhancements that we will do for the ABL platform as well. We have also added the ability to convert a variable length extent to a fixed length extent of a size specified by the user. When you define a database, you define multiple extents, and the extents are where the data gets stored. The progress recommendation is always to have the last extent be variable. The reason we do that is so that as your database fills and you get into the last extent, it will continue to be expanded as more data gets entered into the database. But there's a cost to extending a database. It's an expensive operation from a performance point of view. we now allow you to convert a variable extent to a fixed extent of user-selected size and add another variable extent on the end of that database chain. Lastly, we modified the way the database logs are handled. You can now configure database logs to automatically be archived and truncated based on the size of the file, the time of the day of the week, or various other parameters. Let's shift gears now and talk about application recovery. Sometimes bad things happen and we have to recover our system. Let's look at some changes that are being made in that area. OpenEdge replication has been around for some time now. OpenEdge replication allows you to take a database, which is on a production server, and replicate it off to another server in near real time. In the event that the source becomes unavailable, you can transition your users and your applications to use the target system with minimal disruption. We've changed the way OpenEdge replication works, and I'm going to describe that in the next couple of charts, which will help you understand the image that you see on the screen right now. Let's take a look at the way the original process for OpenEdge replication occurred. In step 1, a transaction occurs, and that information gets written onto the primary or active production database. At the same time, a marker is put in the Pica queue that says a change has occurred on the primary database that needs to get transmit to the target database. The replication server pulls the first request off the Pica queue and transmits it to the target system, where the data gets applied. A notification is returned to the replication server saying I'm ready for the next change, and the replication server works its way down the queue in sequence. When we get to version 12.0 of OpenEdge, we've changed the way replication works. The beginning of the process is very similar. A transaction occurs, the data gets written to the primary database, a marker gets placed in the Pica queue, and the replication server monitors the Pica queue and transmits the change to the target system. What's new is that on the target system, we've added an RSB queue. Now, the name of the queue isn't important. What is important is that we have a place where we are storing the changes. The replication server transmits the change over to the RSB queue, which is a very fast and efficient transfer of the change. Immediately after that, the replication server is available to transmit the next change. In parallel, on the target system, an agent writer thread is looking at the RSB queue and doing the much longer process of writing the change onto the database. So you might look at that and say, well, all you really did was add another queue. But the benefit of that queue is that you've moved the change onto the target system. And should the source system become unavailable, the target system already has the change and it will apply the change in time. Let me show you how that works by looking at the latency of when the changes gets transferred on the source system. Under the original version of OpenEdge replication, a queue would build up on the source waiting to get transferred to the target system. This is shown by the green line. If during that time the source went down, that change would not get transferred to the target system, and your target system would be out of step when you transferred your operations over. Under the new version of OpenEdge replication, changes to the primary database get transferred almost instantly to the target system, as shown by the blue line on this chart. In contrast, on the target system, we now get a queue that builds on the target system, with changes waiting to get applied to the database there. Where in the past, changes transmit to the target system were immediately applied to the database. So what does this mean for you? In the original implementation, there was a potential for clients on the source to get blocked. If the Pica queue filled up with changes waiting to be transferred to the target system, new transactions could not be accepted on the source database, and users would have to wait until the Pica queue was freed up. In the new implementation, the data is transferred much faster to the target system. As a result, you can reduce the amount of resources that are reserved for the Pica queue, making more resources available for your production application. Your data integrity is also improved because the data gets transferred from the target system almost instantaneously, so it's almost impossible to lose data. And finally, if you want to improve the performance of your target system, you can multi-thread the application of those changes to the target database. For the first part of this presentation, I focused on availability. Now we will transition to focus on security in OpenEdge. Much like you've been evolving your applications, we have been evolving the application platform and continually adding security enhancements to it. The first security enhancement that we added was Client Principal, which was added in version 10 back in 2003. The Client Principal represents a verifiable, unique, successful user authentication. A user logs onto an application with a user ID and password, and a token gets built based on that information and the access the user is allowed to have in the system. From that point on, OpenEdge doesn't allow the user access to any resources until it has verified the token for corruption, expiration, and authenticity. When using Client Principal, all login and logouts of the users are recorded into an audit log. Throughout the OpenEdge topology, we use a Client Principal internal authentication. But it's become popular over the last several years for external authentication schemes to be used as well. We accept external authentication tokens and convert them into Client Principal tokens for use within the OpenEdge topology. One thing to note about the Client Principal token is that once the token is sealed, it cannot be changed. So an unauthorized user cannot get into your system and corrupt it or pretend to be a different user. Throughout the rest of the presentation, I will refer to the OpenEdge topology that you see here, which is a typical implementation of OpenEdge. And I'm going to show you where security has been added. Throughout the topology, we used the Client Principal. In version 10.1, we added database auditing. Database auditing records any changes to the database. It records the before condition of the data, the after condition of the data, who made the change, and when they made the change. It is stored in a format that cannot be modified, so it provides a secure record of activities within your system. Another enhancement that's been made in security is data encryption. Many users and developers want to secure data that is stored in the database. And there are several ways to do that. One way to do that is by disk encryption. Disk encryption requires encrypting all the data on the disk. While this is effective, there is a cost to encrypt and decrypt data, and there are many fields of your data that do not need to be protected, such as city names, state names, zip codes, telephone numbers, and so on. Full disk encryption does more than it needs to, and you pay a cost for that. The second way to protect data has been to do programmatic encryption through the OpenEdge application. This allows you to selectively choose which data you want to encrypt, but the downside of programmatic encryption is that you had to write the encryption program and you have to maintain the encryption program. Should the algorithm that you are using become compromised, you need to go back into your code and make code modifications to implement a new encryption cipher. OpenEdge has introduced transparent data encryption, and transparent data encryption is truly transparent. There's nothing in your application that needs to change in order for you to take advantage of this feature. The way transparent data encryption works is when data is written from the buffer onto the disk, the data gets encrypted en route. And then, when data gets read off the disk, it gets decrypted as it moves back into the buffer. So transparent data encryption protects data at rest, but you also have data moving within your system. OpenEdge supports SSL and TLS, which are security processes within the HTTPS protocol. Another enhancement we made for security in OpenEdge is multi-tenancy. Now, you might not think of multi-tenancy as being a security feature, but if you ask 3 customers to put their data in the same database, they will immediately raise security concerns. Multi-tenancy allows multiple users to use the same database, but it builds a firewall between each user so that each user can only access their individual data. It is very popular now for users to want to use single sign-on. Single sign-on allows a user to sign on once and be granted access to multiple applications within a system. However, that creates a challenge for developers and operations personnel who still want to maintain the security of the environment. In OpenEdge, we use the client principal for single sign-on throughout the topology, which means that the same level of ID management and trust is used in all your applications. And there is central user authentication auditing available. This eases the administration for developers and the operations team. In version 11.5, we introduced the Progress Application Server for OpenEdge. The Progress Application Server for OpenEdge is built on industry standards of the Tomcat Application Server and Spring Security. This enhancement makes the OpenEdge environment mainstream. The benefit to you is increased security of the Spring platform, as well as an increase in the availability of resources skilled on the platform. Over the years, we've heard from customers and partners that availability of trained OpenEdge resources has become limited. The move away from the former proprietary application server to an industry standard application server that is taught in the nation's colleges and universities increases the pool of resources that understand how the Progress Application Server works. Once we had the Progress Application Server rolled out, the next thing we did was to create the OpenEdge Authentication Gateway. This came to us through a requirement of one of our customers in the financial industry. They were engaged in an audit, and the auditor said, "Tell me about access to your database." Our financial customer replied that their users access the user tables to determine what they are authorized to do within the database. The auditor said, "So let me make sure I understand this. Your users access the database to see if they're authorized to access the database." As you might suspect, that didn't pass the audit. This led to the development of the OpenEdge Authentication Gateway. The OpenEdge Authentication Gateway is another Tomcat application running in parallel with the Progress Application Server. The way it works is the user logs into the OpenEdge Authentication Gateway, which has its own database for user ID and password, and tables that define the resources a user is authorized to access. Once in the Authentication Gateway, a token gets built, and that token gets passed to the Progress Application Server, where the token gets used to access the primary database. Another comment on the OpenEdge Authentication Gateway is that it can be used with the Classic App Server. So if you are still working with the Classic App Server but would like the benefits that are provided by the OpenEdge Authentication Gateway, it can be stood up in a Tomcat environment next to your Classic Application Server and used for authorization and user sign-in. Another popular industry trend is the use of external authorization servers such as OAuth 2 and SAML. The Progress Application Server for OpenEdge works with external authorization tokens and converts them to client principal tokens for use within the OpenEdge topology. Spring Security is an evolving standard. It gets changed from time to time, and as it changes, Progress enhances our products to take advantage of the newest enhancements. In version 11.7, we made some modifications to Spring Security configuration. Our original implementation required you to edit XML files. This can be tedious and error-prone. The new configuration is based on properties. We have also added a tool that allows you to script security changes. And as mentioned in the earlier slide, Spring Security includes SAML support, OAuth 2 support, and is an integral part of our OpenEdge Authentication Gateway integration. Lastly, we have removed some vulnerable ciphers that have been compromised and are no longer viable. Security can be a very complex topic, and as you have seen in the previous slides, it can be applied in many parts of the topology. Progress Services has created a security health check that will help you evaluate and implement security to take advantage of the latest enhancements in our product set. The security health check involves 3 steps. The first is a survey to understand what's working in your environment and where there might be some vulnerability. The second is education on what's available and how to implement it. And finally, the building of an implementation plan and the implementation. The health check is run in 2 phases. The first phase involves a survey and an understanding of what vulnerabilities exist in your environment. That phase concludes with a recommendation for changes, a customized project plan, and a statement of work to perform the changes. At that point, you can decide to make the changes yourself, or you could hire our professional services team to implement any or all of the capabilities that you see on the right side of the slide. When you think of application evolution, you often think of the front end and the glitzy part of the application. I encourage you to remember that security and availability should also be included in your evolution plan. Here is another customer testimonial talking about their view of the OpenEdge 12 capabilities and the fact that continuous operations, performance, and security are critical dependencies for their operations. I'd like to finish with a couple of proof points where our customers are implementing security and availability measures. The first is Unicorn, who offers a payroll and benefits application. By implementing our Progress Application Server for OpenEdge in a SaaS environment, they were able to build a competitive advantage which allowed them to significantly grow their market share. Another proof point is Gaming Hospitality Solutions. They are very big in the casino industry. Casinos run 24 hours a day, 365 days a year, so system availability is a critical factor for success. Gaming Hospitality has implemented OpenEdge replication to maximize data availability. They replicate both on-premise and off-premise and are very satisfied with the results that they have received with that implementation. To learn more about security and availability, there are many resources available on the Progress website. That concludes the presentation. Thank you.